Okay, let's consider another problem, propane problem. And this is an example of the kind of question that and situation that we've been talking about. This is the ability to make predictions. In an industrial process, I will want to know if I have this much of my reagents, then how much of each of my products am I going to make? It's a very basic but very important chemistry question. So, example. Propane is a combustion reaction, burns in a combustion reaction. Combustion reactions are where you add oxygen and combine and give out carbon dioxide. And if 200 grams of propane is burned, how much water will you make? Also, how much oxygen do you need? How much carbon dioxide are you going to make? And what happens if you don't have enough oxygen or too much oxygen? These are the questions we'll consider in this video and maybe one other. So the stoichiometric equation that we have up there with its stoichiometric coefficients are 1 mole of propane will require 5 moles of oxygen and give you 4 moles of water and 3 moles of carbon dioxide. But what's really important there is the ratio. So rather than say if you have 1 mole, it's better to think of for every mole of propane that you will use, you will need 5 moles of oxygen, you will get 4 moles of water, etc. So for every mole of propane, if you have more propane, then the amount of oxygen you need and the amount of water you'll make will go up. If you have less propane, it will go down. But no matter what happens, the ratio will stay the same, at least in terms of the number of moles. So the ratio of propane to water in this reaction will always be 1 mole of propane gives you 4 moles of water. That's generic. That's applicable to all of the propane reactions that there are. But we don't have a generic, we have a set number. We have 200 grams of propane. So 200 grams of propane is how many moles? How many moles do we actually have? Well, for that we need to know the molar mass of propane. It's C3H8, 3 carbons, 8 hydrogens, carbons each 12.011, hydrogens are 1.008, add it all together, and you get that propane has a formula mass of 44.097 grams per mole. So if you have 44.097 grams, you have 1 mole. We have 200 grams. Well, 50 times 4 is 200, so we're going to have a little bit more than 4. But let's do the maths. We take 200 and we divide that by 44.097. And 200 divided by 44.097 means we have 4.535 moles. So we take the amount that we have in grams, we divide that by the molar mass of 1 mole, and you get 4.353 moles. Now the ratio we just said is 1 to 4. So if you have 4.535 moles of propane, you'll be making 4 times that amount in moles of water. Your quantity will be 4 times higher. Molar mass of water itself is 18.015 grams per mole. We've worked that out before, 2 hydrogens and 1 oxygen. And therefore, given that we have 18.142 moles, and given that each mole has a mass of just over 18 grams, that adds up to 327 grams of water. So let's just recap. We know the ratio in moles. 1 mole of propane gives you 4 moles of water. We know the molar mass of propane, so given that we know how much propane we have, 200 grams, we find out how many actual moles of propane we have. It's all about the ratio. 1 mole for every mole of propane, you get 4 moles of water. If you have 4.535 moles of propane, you'll have 4 times that number of moles of water. And 4 times that number of moles of water is 18.142 moles, which when we work out the molar mass of water and multiply it by the number of moles that we have, gives us 327 grams. 200 grams of propane will always give you 327 grams of water. And once you know that, by the way, you can just scale it up. 400 grams of propane will give you double that, whatever that is, 700, should have done this in my head, 654. Okay, So it always doubles. It's all about ratios.